Hello, Mr. Geiselart here, and we're going to take a look at homework number 3, which begins talking about the applications of solving trig equations. This is actually number 3 on that, so if you want to go ahead and open that up and follow along, you can. All these questions are pretty much done the exact same way, so I'm going to do one example for you, and hopefully that'll be enough for you to figure out how to do the other questions. So let me read through the question first. It says Pluto's distance in billions of kilometers from the sun can be modeled using a sine or cosine equation. At year t equals 0, Pluto is at its average distance away from the sun, which is 6.4 billion kilometers. After 10 years, it is at its closest point to the sun, which is 4.8 billion kilometers away. So the first thing we want to do here is we want to decide, should we use sine for this or should we use cosine? Well, you're going to use sine if the information you're given is the middle. Now, another way of saying middle is saying average. You would use cosine if you started at a max or at a min. Now, in this case, I'm given the average distance, so that means I want to go ahead and use sine. So I'm going to use my sine. Now, the next thing I'm going to do is I'm going to graph this. Now, in order to graph this, I know I'm using sine, and then I'm also given the minimum. So the minimum distance away is going to be 4.8 billion. So let's go ahead and before we actually graph this, let's go ahead and do our maps. So we're going to do our middle, our amplitude, our period, and our shift. The other thing I'm going to add into that is finding the max and the min values. So the middle is just the average, and that was given to us as 6.4 billion kilometers. The amplitude, well, I'm not given the amplitude, but I am given the million, which is 4.8. Now, the amplitude is just going to be the middle minus the minimum, which is going to equal 6.4 minus 4.8, which is going to give me an amplitude of 1.6. My period. Well, when we think of this graph, it says that I start in the middle at the average, and then I'm going to go down to a minimum, and then I'm going to go back to the middle, then we go to a maximum, and then we're back to the middle again. So this is basically going around the sun one complete time. Now, when I'm looking at this value here, so from the middle to the minimum, that is 1/4 of my entire period. So if it takes 10 years to go from the middle to the minimum, my period is going to be 10 years times 4, or 40 years. Then the next thing I'm going to do is I'm going to take a look at the shift. Well, I'm choosing to do cosine. Since cosine is going down, I can say that this is a negative cosine. If I make this a negative cosine, then there will be 0 shift. Okay, so let's go ahead and figure out the equation, or actually let's go ahead and graph this first. The first thing I'm going to want to do when I graph this is I'm going to need to make sure that I hit the right one. Now, I'm not actually in a browser right now, so I can't actually hit it, but I'm going to want to hit this one right here. And then I want to start at the middle. So I want to make sure that I click on this graph right here, and I want to start at the middle. The middle is at 6.4, so 6.4 is going to be right there. Then the amplitude is 1.6, or I have to go down to a minimum of 4.8. So it says after 10 years, so I have to go to 10, and then I want to go to 4.8. So 4.8 is going to be right there. Now, those are the only 2 points you're going to need to graph if you're actually in here, but since we're not in here, I'm going to go ahead and plot the other points. So after another 10 years, I'll be another 1/4 of the way through, which will bring me back to the middle value or the average value. Then another 10 years, I'll be at the maximum value. Well, to find the maximum value, that's just the middle, 6.4 plus the amplitude, which is 1.6. And 6.4 plus 1.6 is going to give me 8. So that means I have to go from 30 all the way up to 8, which will be right about there. And again, you're not going to have to plot these points because it will draw it in for you. And then we're back to the middle, which is going to be right here. So the graph will look something like this. Now again, you only have to plot the first 2 points in order to do that. So let's go ahead and write the equation. So to write the equation, and I'm just going to write it right above here so I have a little more room, is going to be y equals. Make sure you put the y equals in there because you're writing an equation. Then we have the middle, which is 6.4. Since we said it was a negative sign, it's going to be minus 1.6 times the sign of. Now, to find my b value, all I need to do is take the period, or 2 pi divided by the period. So 2 pi divided by 40 is going to be pi over 20. And you should leave that as pi over 20 and not write it in as a decimal. And then we just have to multiply that times x. So that's what my equation is going to look like. So now the next thing we need to do is it says how far away will Pluto be when t is 34? Round the answer to the nearest tenth. Okay, I'm just going to erase this, maybe not. Let me try this. There we go. Okay, so I'm just going to erase this so I have a little more room. So what we're going to do here when t is equal to 34, actually the t here is going to be my x value. So time is x. So that means I'm going to write that equation out. I'm solving for y, and that's going to be 6.4 minus 1.6 times the sine of pi over 20 times, and then my time is 34. Now, when I put that into my calculator, I'm going to end up with something like y equals 7.6944 something. Okay, in this case, we just want to round to the nearest tenth, so that will be 7.7 years. Now, you don't have to put in the years part there. We don't look for a label in this particular problem. And then the last one. Now this one's a little bit more tricky. So in this one, what we're going to do is we're going to go ahead and we're going to have to find at what time does it equal 5.4 billion miles away. Actually, now that I say that, when I look at the question here, that wouldn't have been years. That would have been how many billions of miles away it was. So letter C is the billions of miles. Okay, so now let's take a look. I'm going to go ahead and erase this again over here so I can have a little bit more room to write, because I'm going to have to do a little bit of calculations here. So I'm just going to erase all this stuff up here. Okay, so now what I'm saying here is that I have 5.4 billion miles, and that equals my equation, which is 6.4 minus 1.6 times the sine of pi over 20, and then times x. So what I want to do here is solve for x. To solve for x, I have to isolate the sine first. So I'm going to start by subtracting 6.4 from both sides, and that's going to leave me with -1 is equal to 1.6 times the sine of pi over 20x. Next, I'm going to divide by 1.6 and negative 1.6. And when we do that, we end up with 0.625 is equal to the sine of pi over 20 times x. Now we have to do the inverse sine of both sides. The inverse sine on this side and the inverse sine on this side. The inverse sine of sine cancels each other out, so I'm just left with pi over 20 times x. And when I put the inverse sine of 0.625 into my calculator, I end up with that rounding to 0.675. rounding that to 3 decimal places. Now, to finish off solving this, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 20 over pi and multiply this by 20 over pi. And then when I do that, this cancels out over here, and I'm left with x is equal to 4.297. Now, this is just asking it rounded to the nearest tenth, so my first answer will be 4.3. Now, if we look at the graph, what I want to do is say, where is this going to be 5.4 billion? Well, it's going to be 5.4 billion here and here. So this was the first one that we found, which is at about 4.3, and now we have to find the second one. Just like when we're solving the other equations from the previous assignment, in order to solve for that second one, all I have to do is take my sine, or the inverse sine value. So I'm going to take this number right here, and before I solve, I have to do pi minus that number. So I'm going to do pi minus 0.675 is equal to, and then I still have my pi over 20x. So just like we did before in the assignments, in order to find the second sine answer, I have to do pi minus that. When I do that, I end up with 2.467 is equal to pi over 20x. So again, I'm going to multiply by the reciprocal. So I'm going to multiply by 20 over pi and 20 over pi. And when I do that, I'm going to end up with x is equal to 15.703, and when rounded to the nearest tenth, that's 15.7. So when I look at my, just sketching my graph, when I draw this down, it looks like that's about 4.3, it's somewhere in there. And then this one, when I put this one down, if I go straight down from here, that's about 15.7. So my graph matches up with what my equation does, and that's going to do that. So just kind of in summary, the first thing that you're going to want to do is decide whether you're going to use sine or cosine. In order to use sine, that's if you're given the average or the middle information in the diagram. Cosine, you're going to do it if you're given the max or the min. Now, if you're given the max, it will be a positive cosine. If you're given the min, it will be a negative cosine. After you know what you're going to use, then it's just a matter of doing the maps, finding the maximum minimum, and once you have the equation, enter in the variables, or enter in the data into the variables, and that will give you the answer when you solve. Over 20